Hello everybody and welcome to this lesson on the basics of simultaneous equations. So, being able to solve simultaneous equations is one of the more advanced tools in your basic algebra toolbox. So this lesson today will aim to show you how to solve simultaneous equations by a method of substitution. Please note that there are two ways to solve simultaneous equations, and both of them have different applications, so one is better for different situations, vice versa. Okay, so starting today, we've got 4x plus y equals 17, and we've got 2x plus y equals 9. We've got two separate equations here, and our aim is to solve them simultaneously, meaning at the same time. Okay, so the problem with simultaneous equations is we often have two unknowns. So if I show you, we've got x and we've got y, and the same on that side. So if we look back at an equation that we're more familiar with, perhaps a linear equation, so something like this, x plus 3 equals 5, you'll note that we only have one unknown. We know that we are solving for x, so when we solve for x, all we have to do is take away 3 from both sides, so we get x equals 2. That is from your basic algebra course. Right. Now looking at our simultaneous equation, it's a little bit different. We've got x's and y's, so we need to find a way to solve them at the same time. So let me guide you through this step by step. The first step is always to label your equations. So I'm going to call the first equation number 1 and the second equation number 2. The next step is to choose which equation you think is actually easier to solve. So this is quite subjective. Some people will think something and some people will think something else. It doesn't really matter. So I think equation 2 is easier to solve. So I'm going to use equation 2. So using equation 2. There we go. Now that I've chosen an equation that I think is easier, I'll need to isolate a variable. So looking at it, I've got x's and y's. I've got 2x plus y. Well, y is going to be easier to isolate in this case because it's already by itself. We have a 2x there and I'd have to deal with the 2, and I'd like to do this the shortest and the easiest way possible. So I'm going to isolate for y. Y equals. Okay, in order to get y on its own, we've got a 2x there. So let's take away 2x from both sides. That leaves us with y equals 9 minus 2x. And this is going to be a really, really important little magic key for us when we move forward. We figured out that y equals 9 minus 2x. We have expressed y in terms of x. The next step is we need to use this little magic formula and put it back into equation 1. So put it into the equation that you did not use. So I didn't use equation 1. So substituting into equation 1. So that basically means any time that I see a y in equation 1, instead of writing y, I'm going to write 9 minus 2x. So it's going to look something like this. 4x plus, oh look, that's a y. So instead of the y, I write 9 minus 2x equals 17. Now I've got this little equation here. It needs to be tidied up a little, because if we remember our basic rules of algebra, we need to group variables that are similar. So we've got 4x minus 2x, that's going to give us 2x, and then we've got a plus 9 equals 17. Now this looks like something that you've solved before. So when we solve for algebra, we want to isolate the x. What's stopping us from having the x on its own? Well, there's a plus 9 there. So let's take away 9 from both sides. So 2x equals 8. Okay, what's stopping us? Remember that 2x actually means 2 times x. So we need to divide by 2 to isolate x. So x equals 4. Okay, so we've solved for x, but the problem is we don't know what y is. But if you look back at our little magic formula, we actually do. We know that y equals 9 minus 2x. So y actually is 9 minus 2 times 4. So remember this bracket notation here, that actually means 2 times 4. So it means y equals 9 minus 8. So y equals 1. We've actually solved this equation. Great. Now we've learned how to solve our first simultaneous equation by substitution. Now I've got a relevant exam question here from you for the 11+. I've taken this from the Manchester Grammar School paper from 2016. It says, Rachel buys 3 identical bags of sweets and 5 cans of drink. The total cost of these items came to £4.90. Rosie buys just 1 bag of sweets and 3 cans of drink and pays £2.70. What is the cost of a bag of sweets? Now, how can we tell that this is a simultaneous equations question? Well, first of all, we have unknowns, and this points us to the fact that we need to use algebra. And secondly, there are 2 statements. Rachel buys a certain number of things for a certain cost, and then Rosie buys a certain number of things. This points us to the fact that there are 2 equations that need to be solved. Hence, this is a simultaneous equations question. Okay, let's try and solve it. So we need to write 2 algebraic equations. Let's start by doing the one for Rachel. So she buys 3 identical bags of sweets and 5 cans of drink. So we need to give letters to the unknowns. So to make this easy, let's call sweets S and drinks D. Okay, she buys 3 bags of sweets. How would we write this algebraically? Well, that would be 3 lots of S, written as 3 times S. But remember, in algebra, we don't write 3 times S, we simply write 3S. So that would be 3S plus 5 cans of drink, 5D, with the total coming to £4.90. I'm omitting the pound sign just to make the equation a bit simpler. Let's do the equation for Rosie. This would be a perfect time for you to pause the video and have a go yourself at writing the expression for Rosie. Okay, she buys 1 bag of sweets and 3 cans of drink. So that would be S plus 3D equals £2.70. What might have caught you out is that you might have written 1S. Be careful with that, because the proper algebraic notation is to write S only. We tend to not write 1s in algebra where we can avoid it. Okay, now it's time to solve. So the first step to solve simultaneous equations is always to label our equations. This helps us keep our work nice and neat. So 1 and 2. Okay, now we pick the simpler equation. I think 2 is simpler. And then we choose a variable to isolate. So out of the variables S and D, I believe S is easier to isolate. So I'm going to use equation 2. And I'm going to isolate S. So S equals, well, what's stopping me from having S on its own? It's going to be the 3D. So I'm going to take away 3D from both sides. That leaves me with S equals £2.70, take away 3D. And this now becomes our magic formula. So we need to remember this. So we use the equation that we didn't use, so using equation 1, and then we substitute. So anytime we see an S, instead of S, we're going to write £2.70 minus 3D. Okay, so it starts with 3 and then lots of S. So 3 bracket £2.70 minus 3D plus 5D equals £4.90. Now we've got a bracket to expand here. So if you don't know how to expand brackets, make sure you check out our video on expanding brackets. But all we do is multiply. So 3 times £2.70 is £8.10, take away 9D, plus 5D equals £4.90. Okay, now we've done the substitution. That was the hardest part. We just need to tidy up this equation now. Okay, so we've got minus 9D plus 5D, that will be minus 4D. So we've got £8.10 minus 4D equals £4.90. We don't like having negative unknowns, so we don't want minus 4D. I'd rather that be positive, so I'm going to move that to the other side. So that's going to become £8.10 equals £4.90 plus 4D. Okay, so now I want to get the D on its own. So we need to do £8.10 take away £4.90. That's going to be £3.20. So £3.20 equals 4D. Now to isolate D, we need to do £3.20 divided by 4. So now we know that D equals 0.8 or ATP. So drink equals ATP. Okay, we know how much a can of drink is. This is going to help us find out how much a packet of sweets is. Well, we know from our magic equation that S equals £2.70 minus 3D, and we know that D is ATP. Okay, so now let's just substitute again. So S equals £2.70, take away 3 lots of ATP. Okay, so that means S equals £2.70 minus £2.40. S equals 0.30, which is 30p. So 1 packet of sweets is 30p. We'll just underline our answer. So there we go, we've solved the question. So I hope that this video has been helpful to those of you struggling with simultaneous equations, or just those of you that want a recap. So this is the method of substitution, and this works well mostly when you have a variable that has a single unknown. So you'll be able to recognize when you want to do substitution when you have two equations where one equation has a variable that's by itself. That makes it easy for us to substitute. Make sure to tune in for our video on elimination, where I'll explain in which situations elimination might be the best bet for you to solve your simultaneous equations. Thank you for watching, and keep practicing.